Okay, this is the first of two videos where we'll examine how to find the most efficient surface area for a given solid with a given volume. In this case, we have a hexagonal prism and our given volume is going to be 500 cubic centimeters. Your solid's going to be different and your given volume is going to be different, but you'll just go ahead and use whatever it is that's given to you. And to start, you're just going to pick any side that you want, just a guess. And we're going to use a trial and error method to find that most efficient surface area. I'm just going to go ahead and guess 3 for the length of a side. So what I'm saying is that if this is an equilateral base, all the sides are 3, what would the height then have to be for this volume to have 500 cubic centimeters? So just working with the base with the side length of 3, the formula for the area of a base of a hexagon, we got that special formula, 6 side squared root 3 over 4s. The other types of shapes for bases might be a little bit harder than this. So they may take some trigonometry or some other work. But for this one, it's already written in terms of side. So we know that this is 3 squared root 3 over 4. Okay. So all we have to do is get our calculator. I've got it already set up for this one. Okay. So 6 side squared root 3 over 4 would be about 23.38. We're going to store that here. We're going to store that in alpha B. Okay. That way we have the entire base stored in a letter and we just need to recall that letter. So we'll go ahead and put that 23.38 here. 23.38 is our base area. And now we need to find the height given that particular base area. So the volume is equal to the base times the height. Our given volume is 500 cubic centimeters. So we'll just plug in 500 for volume. It's equal to base times height. So our height will be 500 divided by b, simply dividing both sides of this equation by b. So that's all you have to do since you have this stored in b. Just go ahead and type in 500 divided by alpha b, and there's your height, 21.38 rounded. We can put that into our height right here, 21.38. Okay, and so now we have the base area and the height that will give us our volume. Now we could check this very easily. We have a base, we have a height. Let's go ahead and just clear out the screen and just see what we get when we multiply base times height. Did I store the height in? I may have. Base times height, 500, exactly. Okay, so now that you have the base and the height stored in, we can work backwards with this formula right here to find the surface area with these given dimensions. The perimeter of the base is going to be 6 sets of 3. So the perimeter of the base is going to be 6 times 3 times the height. There's your perimeter of the base times the height, plus 2b. I don't even have to write those numbers in because those are stored appropriately. And we'll just go over here and go 6 times 3 times alpha h plus 2 alpha b. Right there. Hit enter. And we get a surface area of 431.67. We'll say 67 rounded. 431.67. Put that on our sheet. 431.67. Okay, so for my guess of 3 for every side, we get a surface area of 431.67. I don't know if that's going to be good or bad, but when I go to this chart, I'll go ahead and enter everything in. So our guess was 3.0. The height ended up being 21.38. And the surface area ended up being 431.67. In another video, we might have this chart filled out, and then we'll kind of use hot and cold to guess either bigger or smaller to get the lowest possible surface area possible. Hope this video helped.